Oh, never mind. Thought we were all gonna hum together. Hey everybody, how's your intermission?
Yes! Very nice.
Awesome. We are 6 Degrees of Science. I'm Joe Vanderhelm.
I'm Kory Mathewson.
Has anyone here seen the show before, maybe last week or anything like that? Okay, cool.
Okay.
Woos. So what we do in our own personal lives as improvisers is we love science.
Absolutely.
Yeah, I'm a general science major. I teach high school chemistry and some physics.
Physics, yeah.
I have a bachelor's degree. Kory Mathewson.
Yeah, I have a bachelor's in electrical engineering, a master in biomedical engineering, and I'm doing a PhD in computer science and artificial intelligence.
Yeah, give it up for Kory.
Yeah.
He is currently working on building the robots that will send people back from the future to fix, and they're gonna be talking to you.
Yeah.
Like, Kory, don't build that robot.
Like I'm gonna be the person time travelers try to kill.
Yeah, exactly. That's you.
I'm very worried about time warriors every day I get up.
Just don't invent that device.
I guess so, yeah.
Okay, my shirt is a pun. Does anyone know the pun on my science shirt? Ooh, okay, some people are saying iron wheel because you recognize that Fe is
the classic
elemental
pun,
symbol for
iron wheel?
Yeah, it's not an iron wheel because these aren't the atoms of iron, they're the ions of iron.
Come on, you're so close though.
And in the classical naming, like nowadays we look at this and we say it's Fe2, iron 2.
It's a what?
Ferris wheel.
Yes!
Ferris wheel.
Yes! Does anyone know what the pun on my shirt is? Bilingual, yeah.
You guys nailed it.
Thank you very much. They didn't, they were sold out of the ones that said Pi Curious. So I had to go with this one.
I want to just go back real quick to how amazing Resonance was. In their first song, they sang about combustion.
Ooh.
And that got me personally very excited.
Very hot.
Very hot. Do we know what combustion means in the world of chemistry?
Classic.
Oh yeah! What? Oh yeah!
Oh yeah.
Would you like to share with the class? Yeah, you're talking about a hydrocarbon combustion. Specifically, combustion means reacts with oxygen. And you're doing it inside your body like 1 trillion times per second right now with cellular respiration. It's the thing that's keeping you alive. So that's great. Yeah, there, there we go.
Cellular
awesome.
respiration is what it feels like when you're chatting with someone in a long-distance relationship.
And all they hear is...
Yeah. That's cellular respiration in my brain.
And then later they talked about how forest fires from death of a forest can bring life. Into
so
a forest.
beautiful.
And we were all mesmerized by the metaphor, but there's good science there, people.
Yeah.
Really good. Do we know why forest fires are so important?
3 good reasons. What?
Right. Well, because what about those pine cones? Yeah,
Exactly.
They got seeds inside, and they need the heat of the fire to like send those, and that,
like popcorn.
Yeah, like popcorn. But also, it returns the nutrients to the soil, so that when those seeds pop out, they're like
carbon,
ready to go.
Nitrogen.
Yep.
Phosphorus.
Yeah. And then also, if the forest was unhealthy, like if they had a disease or anything like that, then just gone.
Easy.
Slate.
Dutch elm disease, peace out.
So as you can see, we're really into science. And so our show sort of fuses our love for science and our love for improv. And to start us off,
is there anyone here who loves science? Okay, cool.
Is there anyone who watched the series finale of Mythbusters today? It's over.
What?
It's done.
Spoiler alert.
How was that a spoiler?
Well, they all die at the end.
It was their... Oh my God, the biggest explosion ever in Mythbusters history.
Yeah, just like myth confirmed.
Yeah, explosions kill. Huge exothermic hydrocarbon combustions kill.
Oh no.
It's the silent killer.
No.
It's not silent at all.
Grant Imahara.
All right. Gravitational waves was huge in the news.
Oh yeah, give it up for gravitational waves, everybody! Yeah!
All right, so what we need to get us going, we're already going, but from you...
Was that just some observational comedy on gravitational waves?
You inspired me earlier when you were doing your bits.
That's beautiful.
What we need to get started is any concept formula or equation that you remember from junior high or high school science or math classes. So in the past, we've had a lot of the ones that are in Kory's shirt, area of a circle.
Yeah.
People have thrown out like Schrodinger and stuff like that. That's not really
Heisenberg's uncertainty principle.
Yeah, that's getting pretty high.
We did general relativity one time.
Oh, last week we just did like periodicity, just like the periodic table as a concept, and that was fun for me.
Me too.
Okay, all right, good. So what we need is something like that. So whatever concept, equation, or formula you've got, what do you got?
Second law of thermodynamics.
PV equals nRT, second law of thermodynamics.
Oh, PV is equal to nRT?
Which is very connected to the, yeah.
I mean.
What do you call that? In your head, what do you call that? Let's do that one. Give it up for PV equals nRT.
All right.
Yes. We'll get there, I promise. So this equation's super exciting. In my head, when I learned it in chemistry, I always called it the perv-nert equation.
Which is funny because it sounds like pervert. But it's actually the ideal gas law. Ooh. Of course, we all know that gases aren't ideal. None of us are perfect, and neither are gases. But the ideal gas law assumes that gases will behave ideally, and for like 99% of the time, they do. P is the pressure that the gas is under. V is the volume that gas occupies. N is the amount in moles that we have of that gas.
Moles? What's a mole?
Guys,
you should get this part.
I mean, other than a little, rodent creature, the mole was proposed by Avogadro as a means of knowing the number of particles in a certain amount that he called a mole. And it's 6.02 times 10 to the 23 particles of a substance. So if you have 1 mole of gold, you have 6.02 times 10 to the 23 particles of gold. If you have 1 mole of water, you have 6.02 times 10 to the 23 particles of water.
That's a humongous number.
Like, I'll write it out and you guys won't even know.
10 to the 23. Just imagine all the stars in our solar system, and then multiply that by at least 4 more times. Then, erase that number from your mind.
My kerning was bad, my font size was large, I had to wrap around, so you don't really get the full picture. It's unimaginable.
That's huge.
Yeah, it's really big. And then R is the ideal gas law constant, 8.314 kilopascal liters divided by moles kelvins. And then T is temperature, which also needs to be absolute. So it's not in Celsius, it's measured in kelvins.
Kelvins are very important because we're imagined by this man named Lord Kelvin. Because back in the day, science was done by the elite, the social elite.
And what's cool about his scale is that there's no negative values. So when we've Celsius, -30, oh, it's cold out. In kelvins, we would just be like, oh, it's 243 degrees today. Because that would be -30. But 243 makes it sound like it's way nicer out.
Exactly.
Yeah, so that's the ideal gas law.
So a direct corollary from that is that you can find the changes in a thermodynamic system just by knowing that this is always going to be true. So P1 V1 equals P2 V2. So the initial pressure, initial volume is going to be equal to the second pressure, second volume.
Yeah, so if pressure goes up, then volume has to go down. If volume goes down, then pressure goes up. Like if you've ever had to move from a larger place with maybe some roommates into a smaller place with the same number of roommates.
Yeah.
All right.
So that's your room.
And that's your room.
Yeah.
They are right next to each other.
Yeah.
Cool. I got some more boxes.
Me too.
Sorry, this one's yours.
It says my name on it. See, it's
yeah. And this one says my name on it.
Classic though, similar box.
Yeah. U-Haul. You got your boxes at U-Haul.
Yeah.
Yeah, me too.
Yeah.
That's why they say U-Haul on
Yeah,
it.
they're the cheapest.
Well, I mean, outside the KFC, that's the cheapest.
Yeah, I don't want stinky chicken clothes.
No. Oh, yeah. That box is from KFC.
I would prefer it if you kept it sort of away from my stuff. I don't like the stink of chicken. I'm actually vegan.
You're vegan.
Yeah.
Cool.
I'm sorry, we should have got to know each other a little bit more.
Yeah, the ad was pretty vague, just like roommate needed now.
I did need it right now. Yeah, my other roommate passed away.
Oh my God. Oh, I'm so sorry.
No, it's okay. It's cool.
No, that's terrible.
I had nothing to do with it. So.
No, I mean, I wasn't thinking that before. I mean, now how did he die?
Lack of oxygen.
Anaerobic respiration.
Yeah.
Shit. That's the silent killer right
That
there.
is the silent
that is
killer.
The silent killer.
Yeah.
Yeah, carbon monoxide.
So thank you for making this work.
Yeah, no problem. It's smaller than I mean, the photos I guess were all taken with like a fisheye lens.
Yeah, I'm a photographer too.
Wow, cool.
Yeah.
Oh, that's awesome.
Do you have a nickname or something? I prefer.
Like you want to shorten Jason?
Yeah. I just didn't know what to call you, if it was like Chase or.
Yeah, I know. I mean, yeah, Jay or Jace. Jaw. Don't call me Jaw. That one's dumb. No, that one's dumb. Don't call me that one.
That's all cool, Jaw.
Oh, what about?
I got some stuff in the fridge. I already loaded in. You want a beer?
Oh my God, yeah, that would be great.
You
I
drink
would love
beer.
a beer. I love a beer.
Cool.
Yeah.
Awesome.
That's awesome. What should I call you?
Cassandra.
Like not Cassie or.
Just Cassandra's cool.
I mean, we're taking my 2-syllable name and we're making it one. I just feel like we could do something with your name. It's 3 syllables.
It's cool. Whatever comes up, it's fine. It's gluten-free beer too.
You're vegan and gluten-free?
Yeah.
Okay, cool. No, that's
I'm
cool.
on a hologram diet.
I have no idea what that is.
It's just I eat the shadow of things. Yeah.
No.
Yeah.
No, you can't gain nutrients that way.
Sure you can. Yeah. There's a lot of energy contained within things we don't necessarily think about. Have you ever heard of psyllium husk? Tons of energy in psyllium husk. You know when you peel carrots?
Yeah. I've peeled carrots. Sure.
Okay.
Yeah,
So what do you do right before you peel them?
You wash them.
Right. I eat that water.
I have a lot of questions right now.
Sure, yeah, please. I mean, we got lots of time. We're unpacking. I got that Malm desk from IKEA, so we're going to be building that for a little while.
I'm gonna start with. I'm gonna put these in a priority, going from like least priority to most priority. How do you eat how do you eat water? Like, are you chewing it?
Yeah.
Okay. No, that takes care of that one.
Yeah. That's what I needed the back room for. I have a large ice block that I shave off, and then I fill it with the ice shavings.
Runoff water.
Yeah.
Okay, so if you're not eating solids, like you're not eating real carrots.
I would never, ever.
As a vegan, you would never eat a carrot.
Never would eat in
you're
my
on a
life.
shadow, you're on this weird shadow diet.
It's called the hologram diet, please.
I'm sorry. I'm sorry.
I'm trying to be considerate about your stuff.
You have carrot runoff water. Where are the carrots?
I throw those all out.
Okay, I will happily eat those. I will eat those carrots.
Cool. So we can go halfsies on those.
Okay, sure. We can go halvesies on that.
Right on.
And the third question, and the most important question is,
Yeah.
how are you alive? Like, how are you possibly sustaining your body with carrot runoff water and energy from psyllium husks?
I used to be morbidly obese. You're seeing me at a very interesting time in my life.
Oh.
I used to be at least this large. So I've packed in.
Wow. Oh, that
kind
of explains the small place then.
Yeah. This is a photo of me.
Like one of those panorama iPhone shots.
Yeah. I could only do landscape mode. I've never been able to do a selfie.
Not even like with one of those sticks? Not even a...
No sticks long enough to capture my equator.
Okay, I feel like I've been...
No, this is... I'm just trying to get to know you a little bit.
And thank you for sharing this about you with me.
Yeah.
That's... congratulations on losing so much weight.
Thanks. 1 ton. I'm up to 1 ton.
No!
Yeah. Feels like I'm dancing every step I take.
Like a metric ton or an imperial ton? Are we talking like 1,000 kilograms or 2,000 pounds?
1,000 kilograms.
That is so much more.
Yeah.
Wow!
Yeah. I still have sleep apnea though, so it's...
You got like one of those machines.
Yeah, it's quite loud. I hope you're not bothered by the loud...
No, I'm a really sound sleeper.
Okay.
I can sleep through anything.
Cool.
Yeah.
Let me just hook it up then.
Cool, it's like a Darth Vader thing. That's fun. That's great.
That's not going to bother you?
No, that's totally fine. I'm appreciative for this opportunity.
Cool.
I'm really excited about this situation.
Yeah.
Going halvesies on the carrots is fine by me.
Yeah.
Are
you new to Michigan?
Yeah, I am. I'm here for school, so.
Oh, awesome.
Yeah.
U of M.
Yeah, go Wolverines.
You know it.
Yeah.
Yeah.
I think I do.
You do know it.
Do I know it? Oh, damn it.
You don't know it.
Oh, sorry. The walls are so thin here. Hey, neighbors. What's the mascot for the University of Michigan? If it's not the Wolverines, the Moles?
Go Moles, Michigan Moles!
Go Moles! Okay. You at one point I talked about the equator.
Yes.
I
oh my God, the
I would love
equator.
to focus on not that person's equator, but just the idea of the equator.
Yeah.
And sort of like calculating that, because obviously we just couldn't wrap like a big old like one of those measuring tapes around the Earth. But we were able to discover what the equator of the Earth was using sort of like circle geometry.
Absolutely. Circle geometry, the entire field of geometry is really exciting. What we're trying to do is explore the idea of a sphere.
Yeah.
Very difficult to do from standing in one point.
Right. I mean, for a long time, we all thought the world was flat. And then eventually we realized that there was curvature to our planet.
Yes. Do you know what the curvature is?
Like no.
It's about 8 centimeters for 100 meters.
Oh, okay. So like you walk 100 meters and you've curved 8 centimeters.
Yeah.
Oh, okay, yeah,
Stretch
cool.
that out over a square,
Right.
which isn't very much, but it stretches out so that you can't really see the end of it. So when you look off into the distance,
Yeah.
you can't really see what's over the horizon.
Right. I often joked with my family that, when you get to Lloydminster and you're starting to Saskatchewan, you just see the other end of Saskatchewan. But I guess what you're saying is that that's probably not true.
Absolutely not true.
Would drop off that way.
Yeah, surprising amount. So
but we can all agree that we can see a long way.
Yeah.
Right, okay.
Especially if you had like a tin can, then you'd get like a bird's eye view of Saskatchewan. Yeah. So what is the volume of a sphere? Let's start easy.
Okay, so the volume of a sphere is a ratio that's 4/3, and then pi times the radius of that sphere cubed. So 4/3 pi r cubed is the volume of a sphere.
Pi, very important number.
Right, pi, curious.
Pi relates the diameter of the circle
Yeah.
to the circumference of the circle.
Yeah.
So obviously that would be related in the volume.
Absolutely.
But that still doesn't give us anywhere near the actual circumference around the entire Earth.
Right.
So if we wanted to circumnavigate the Earth, how far do we have to go?
Like far, yeah, far.
But
you nailed it.
Because we know how much the Earth actually curves with every distance, we could figure out where in one point we are, where in another point we are, stick a big stick up, and then see how much of the stick we can actually see.
Yeah. Yeah. I did not know that was a possibility.
It's totally a possibility, and it has been a possibility ever since the ancient Greeks did it ever so many thousands of years ago.
Right, one Greek was just like, hey man, put your stick over there. I'm gonna put my stick over here.
Yeah.
And then like, let's use the same size stick.
Yeah. It was like totally a stick measuring competition, actually.
I've been in enough boys' change rooms, I know what that is like.
Yeah, in ancient Greece, it's all boys' change rooms. I'm just imagining all of ancient Greece.
And one of those symposiums, like, oh, well, let's see your stick.
Okay, and then they're showing each other their bigger.
Like, I'm gonna go stand over here.
Okay, yeah.
And we're gonna look at each other's sticks.
Can I still see your stick?
Yours is a little curvy.
Okay. And that's how we figured out the circumference of the Earth.
Yeah, it was exactly that. That was the exact exchange that took place in a Greek symposium 4,000 years ago.
Yeah, pretty amazing. There's something I want to share about pi. Pi is this amazing number. It's an irrational number, and I love it so much.
We know what irrational means. Not like, But it means that its decimals will continue on for forever with no repeating pattern. It just goes on and on and on, and it will forever go on, and it will never repeat, or at least no supercomputer has ever yet found a repetitive pattern in pi. We sort of know it as the well-rounded version 3.14, but it's not well-rounded at all. It's quite irrational. Well, you're just going.
Yeah, sorry, man.
Can anyone confirm or deny this? No, okay. Then we'll just acknowledge Kory's genius.
Yeah.
He's going to create robots that are going to take over the world.
This
using
number
this.
I'm like pretty sure about, but everything up to that I can confirm.
Okay.
And
wow.
there's someone, this guy in the, yeah, see?
Oh my God.
And that dude's actually a computer.
Did you build him?
Yeah. What? 3-3?
That guy's amazing. Don't let him collaborate with you.
No, I won't.
You guys are going to take over the world with robots.
But pi is this amazing number, and it also is important in this very beautiful formula that I want to share. It's called Euler's formula.
Okay.
Euler's formula is e to the I pi plus 1.
I know all about iPi.
I pi is my pi.
Yeah.
E to the I pi plus 1 equals 0. So
Okay.
this is the most beautiful formula in mathematics, and I'll tell you why very quickly. It relates multiplication, addition,
And nothingness.
and exponentiation.
Okay.
It also has the concept of nothingness, the concept of something, the concept of exponentiation, imaginary numbers, and irrational numbers.
So what? Okay, great, Kory. What can we do with it?
From this, you can figure out all of geometry. The sines, the cosines, the tangents, everything falls from this imaginary number formula.
What about base times height?
Yeah, you can get base times height from this.
That's what I remember from area of a rectangle.
This is base times height?
Well, yeah. Well, that's not really a rectangle, but fine.
Okay, how about that?
Base times height divided by 2.
Okay, all right, all right. Let me ask you this.
Yeah.
If I had a tetrahedron,
Sure.
and
That's imagine a pyramid. Imagine the pyramids of Giza, and then make them 3-sided. So it's like a triangle, then a triangle, and a triangle, and a triangle.
yeah.
It's a 4-sided dice if you're a dice rolling gamer. As clearly I am, I have a collection of dice. There, I said it.
So, how many vertices do you have?
4.
Yeah. How many faces do you have?
4.
Okay. And how many edges do you have?
1, 2, 3, 4, 6. 6. Wait.
This is
Okay.
always going to be true. That's 6.
Okay. Because your vertices
that
minus edges plus faces equals 2?
No, this is wrong already. This, edges minus vertices. Yeah.
Plus faces equals 2.
And that's going to be true for every shape. And
Okay.
that is how we
Is
figured.
that true? Hello. All right.
Edges.
Minus
Yeah. Oh,
6
no,
minus
wait.
4.
Oh, what have I done? What have I done?
I don't know.
Okay, 1, 2, 3.
The first one was right.
The first one was right. I knew it. Why? Who told me I was wrong? Was it the pie guy?
iPi.
So this is true. Well, I'm coming to a point here.
Okay.
This is true about every shape. Is that right? Yeah. Thank you. Not only is this right for this shape, this tetrahedron, it's true for any shape of any number of vertices, edges, and faces.
Okay.
Which means that if you had that and you added another vertex or edge or face,
Sure.
then it would still be true. Which allows us to expand out all the way to the limit to infinity, which is where we would get a sphere.
Oh.
Which allows us to estimate the volume of the Earth, too.
What?
Because
I'm with this guy.
Yeah.
What?
Because
Okay.
if we can measure segments and we can measure points.
If you know the amount of faces, edges, and points, you can also figure out the volume within inside the thing.
Yeah.
No way.
Yeah.
All right, faces, volumes, and points equals get you to volume.
Yeah, but it's because we can extend to the limit of infinity, which is a concept that came like in the mid-turn of the century mathematics, just around 500 AD.
Okay, cool. My idea of extending to the edge of infinity is the end of the world lookout point.
Oh, here in Edmonton?
Yeah, you've been there?
Yeah, I love that place.
It's a great place for like a third date.
Yeah, third date. fucking scary.
Don't be scared. I just wanted to share this with you.
Crazy place.
Yeah, it's beautiful.
So beautiful.
Like you.
Oh. Every time you say that, I love you more. I love you more. I love you, the ancient god of forgiveness. You more?
Okay. Like that would be like if I were to be like, I love you too. Like the Joshua Tree.
Yeah.
What a great album.
Yeah.
Right. Okay. Okay. Oh my God. Oh, that was like so awkward for a second.
I know. I was just getting so excited.
Humor.
Humor
is an ancient god.
Ancient god of
Oh,
forgiveness.
Wow. Of forgiveness.
Of forgiveness.
That's like a Roman or a Greek or what?
Yeah. Roman or Greek.
Oh, okay.
I'm still in the class. I don't know yet. The
right.
finals on Thursday.
Right.
Yeah.
You should learn that.
I should. Oh my God.
Because the finals are on Thursday.
Hello.
Whoa.
Hello. Yeah. Whoa.
Sorry. You're just really close to the
Yeah.
edge.
I thought we were dancing. It was like when we were at the twisted kilt.
Yeah.
Yeah.
Yeah. That was fun. That was fun.
It was so fun. It's
Yeah.
like, it's neat to see you not in a bar kind of situation.
It's neat to see you not in a kilt. You just doing that to like pay your way through school.
Yeah,
Cool.
I am. I have to. It's like, it's
course.
awesome money, but it's like my parents didn't give me cash to go to this school, so.
Right.
Yeah.
Cool.
Yeah.
Humor.
Humor. Humor.
Cool.
Cool. Super cool. Hello.
Hi. Oh. It's weird that you didn't get an echo, but I did. Yeah. I was way less audible than you.
Yeah, it was such a fast echo too.
Yeah.
It's like the sound waves just like, just high-fived your mouth.
Do you want to high five my mouth?
Sure.
I mean,
I got teeth.
I meant with your mouth.
Whoa. Move a little fast.
I'm moving fast. I'm sorry.
Yeah.
I'm sorry.
It's okay.
You earlier professed your love for you more. And I did not think that you were actually talking about a god. I thought you were talking about me. And that's fine because clearly you weren't. And we're at the end of the world, so let's just enjoy this moment.
End of the world, this might be it. This could be the last moment on Earth. This could be the edge.
Yeah, wow. This could be our last day on Earth.
Oh my God. Are you doing everything you want to do on your last day on Earth?
I mean, this is a really nice moment, but I also feel like if you have a feeling about someone or something, you should share that. You should be open and honest about your feelings. So,
Me too.
yeah. So hypothetically speaking.
Yeah.
I mean, what if I did feel like feelings, like loving feelings for you? What if I did do that?
In a hypothetical situation?
I mean, yeah. I mean, like, we're talking hypothetical. What if the world comes to an end?
In that situation, I would say that you probably would want to share that with me. And if you did, I might say yes. It's like an echo. The echo is so crazy.
It's an echo.
Here, it's so fast.
Yeah, it's like you were the echo that
I
time.
was like,
Like, it was like a precognitive echo.
I was like it was screaming in my brain and just like wham, wham, wham. We could spray paint.
You just have a can of spray paint.
Yeah, because I thought that's what you do here. You're like, mark your name in the sands of time to be washed away by the rain.
Or the city of Edmonton employees.
Yeah.
Yeah, let's do that. Nope.
Close
yeah,
though,
like,
close.
Yeah. Yeah, put your name.
My name is Huffer.
It's in a really erratic spray pattern.
Yeah. No?
You usually have those ball bearings inside, but you got the silent can.
Yeah.
That's cool.
That's just air pressure. I wrote my name in half of a heart. I don't know what could come next. I mean, it could be anything. Maybe it was a bird. Maybe it was a bird flapping its wings or like a butt or something. It's not. It doesn't have to be half of a heart.
Okay. I mean, I want it to be half of a heart.
Well,
I want it to be a whole heart when it's together.
Oh my God. That's the most.
Oh, there's a ball bearing.
Careful, careful. You're just shooting into your eyes.
Sorry, I get excited sometimes and it just goes off. Huffer and Steve.
That's so
I
beautiful.
had a full heart. And like a full heart.
I know that it's like so early, but
Wait. Here's your can.
Thanks.
Thanks.
What did you wish for?
On your hair?
Yeah.
I wish that we would have at least one more day on this planet. So we could do this again. Or dance, I guess.
Yeah.
Something's saying we should dance. I have my iPod.
I'd dance. It's crazy to dance outside.
Well, I'll put one earbud in.
Okay.
And like the other one. We've all seen this movie. We know how this works.
Yeah. Yeah, we've all seen this movie. We all know exactly what movie we're referencing here. It's classic. You're just going to play the exact song from the movie. It's super easy.
Absolutely. Everyone knows this song.
Yeah.
It has words too.
I love this part.
I don't know the words. Oh. Do you know how sound works?
Yeah.
Let's talk about how sound works. Okay. All right. Okay.
Yeah.
That was very good for me. I'm not gonna lie. All right. Sound. Sound is a wave that comes from resonance, which is also the name of the people you saw in the second act. You're still hearing right now. So, like solids, right? They're made out of molecules, and they'll vibrate. So when you hit them,
bam!
Those molecules vibrated a lot, and some of that energy became acoustic energy that rippled through the air molecules that are in this space right now. It's the same reason why you can hear me, because I'm making vibrations in my larynx, and it's traveling through this room, and it eventually gets into your little ear holes, and it vibrates against your eardrum, that then through various nerve processes is interpreted in your brain by sound.
Waves are very important. In the world of physics.
And also in the world of West Edmonton. Mark, West Edmonton Mall Wave Pool.
Yeah. And in the world of Mark's Work Warehouse.
Waves?
Yeah, there's like waves of good deals and bad deals.
Very true.
Yeah.
All right.
So the wave can be defined by a few important characteristics. The frequency that it's at, the wavelength.
Right.
That it's actual wavelength. It's
the distance between two crests or two troughs. I taught it in French, so it's crête et creux.
Crête et creux?
Yeah, crête et creux, des crêtes et des creux.
Juste.
Oh, je suis un crête.
Ah, je suis un creux.
Et maintenant, oh, je suis un creux.
Ah,
Un
parce que c'est mal.
This happy little guy, that's the Greek letter for lambda.
Lambda.
And we use it to express the wavelength, which is the distance between two crests or two troughs or two crêtes and two creux, if that's what you prefer.
And this is period.
Right.
Which is the time it takes to oscillate.
Right, to get from one point to the furthest point away and then back again.
Which takes us back to the circle. Quite amazing how that works. And anything in the world actually travels as a wave. Every particle that exists is also a wave.
Right, which is also known as particle-wave duality. And this is where you get your Schrodinger thing in terms of like, oh, is a cat in the box alive or dead? We'll never know, can't open the box. Because it could be both, because electrons get to be both particles and waves, and we're just made up of protons and neutrons and electrons.
This is a critical component because it connects all of energy, all the energy in physics. It connects us to the energy in the thermodynamics. It connects us to anything that's moving in this world.
Absolutely.
So give us a formula for this. Let's say, what if I was a spring, a mass?
Okay, yeah.
You know that?
Yeah, absolutely.
I've
So
got a
you have
mass.
a mass, and there's a spring constant, which is k.
Yeah.
So your period is going to be equal to the square root of m over k.
Yeah.
But also multiplied by the constant of 2 pi.
Yeah.
Exactly.
And that's how long that mass is going to take.
To be like, I'm a mass on a spring. Like those guns, they're like, and there's like a spring inside the gun. Not like a real gun, like a fake toy gun.
Like a Nerf gun, yeah, Nerf gun.
Well, that works on air pressure, but that's fine. Imagine there's a spring in there, like those guns with the orange little bullets that you put in. You pull it back, there's a spring there, and then it goes out. Imagine it was like on a string, so it like went out and then came back in. The time it would take to do that would be the period for that little gun.
Or if it was a pendulum swinging back and forth, it would be the length of the rope and gravity.
And the constant of gravity, which is really neat because what that means is that no matter what's hanging on the end of that rope, it doesn't matter how big that thing is going back and forth. It's going to take the exact same amount of time, whether or not it's like one person clinging to the end of a rope swinging back and forth, or like two people clinging to the end of a rope and like swinging back and forth.
Yeah, this is good. We should go here.
Okay.
Yeah. I like this.
In what kind of a situation would two people be clinging on a rope swinging back and forth?
I don't know yet.
Okay. Wee!
Whoop!
Whoa!
Wee! Whoa! Wee! Whoa! 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 Whoa!
You stopped.
Perfect. Now we ascend up this rope.
And then I crack the vent.
We find Professor, steal the diamond.
And then use the diamond to cut the glass.
Exit out as cleanly as we came in. But
And
on the way,
we
poison his dog.
Ooh, I hate that dog.
He always interrupts his lectures. If just the professor would let us learn for 1 second.
Yes, there's this dog constantly howling and yipping. That's it all day long. Climb. Just keep climbing. The power of perspective means that you're climbing higher. You're so high up now. Okay, now open the vent. Now get into the vent. Oh, you're in the vent now. Now you're in the vent. Yes, move that way. I'm going to climb the rope.
All right, I'll do it just as good as you did.
I'm going to get into the vent. Oh, it's a small vent. Oh. Okay. Oh, there you are.
Yes.
I went right, you must have went left.
Yes. Sorry to startle you.
That's fine. Okay.
There it is.
The professor's room. No sign of the dog. Wait. What if the dog sees us? What if the dog begins to make his noises? Oh, God! It's too late, the dog heard our plan. damn it, we shouldn't have been talking about the plan out loud. They always do that.
Dogs, no, quick, back into the hole.
God. Wait.
What?
What if we just poison the dog now instead of at the end?
Of course.
Poison the dog now, the dog can't make any noise. We can still steal the... Oh, God! Oh, God! Oh, God!
Go.
Okay. Oh. You're awake. You're awake. You don't need...
Oh, jeez, I'm drowning without that thing. Come on, Jace, that's my special time.
I'm sorry, Cassandra, I'm sorry. It's been 3 long weeks. I was under the impression people wore those masks at night when they were sleeping, because it's when you're sleeping at night that you're not aware if you're not breathing.
It got worse. Now my nose closes automatically when I'm awake. It's torture.
It is torture. That is an apt word for what it is.
Did you drink my carrot juice?
No, Cassandra, I didn't drink your carrot juice.
Did you polish off that shadow of a roast beef that I was gonna eat?
Shadows are only there when there's a light source. If you don't have light, you don't have a shadow.
Well, then where did it go? Because I didn't need it.
You turned off the light.
You
turned off the light.
You turned off the light.
You turned off the light. You turned off the light.
I didn't need it.
When you turn off the light, the shadow goes away.
I'm finding you rather hard to live with.
Cassandra, I'm going to move out. I'm so sorry. I have to. For my sanity, I have to move out.
Is there something wrong?
Yes. Yes, Cassandra, there's so much wrong. You have undergone such an amazing transformation. You truly are so special. Yeah. You got the whole world in your hands. And I thank you for these last 3 weeks and getting to know you.
Oh, thank you. Oh my God, thanks for bringing me back here. It's beautiful.
Happy anniversary.
It's where we fell, both literally and figuratively. Oh my God, I tumbled right over this edge, right into your heart.
And then we both literally lost our footing and tumbled down into the river valley.
Yeah.
But we got through it.
Yeah, did we ever?
We became stronger and better because of it.
Yeah. Got a titanium shoulder out of the deal.
Got a psyllium husk heart.
I mean,
so full of energy.
It wasn't too far. The angle's not too bad.
No, just rolled right down.
Yeah.
Tumbling into love. I can feel your heart beating against mine.
60 beats a minute.
Your half and my half.
60 beats a minute, just like our favorite song.
Is that really the tempo of that song?
100% for sure.
Is that a fast song or a slow song?
It's a rather slow song.
I like slow songs with you.
Oh.
I took the courtesy of having the Edmonton Symphony Orchestra.
Oh my God, I was wondering what all those people were doing in suits. Oh my God.
They're here for us.
Even Raj, the triangle player?
Even Raj.
Oh, he's so good at the triangle.
Dance with me?
Of course.
Do you want to do more than dance someday? Like hypothetically?
I mean, yeah, I'd high five your mouth with my mouth. But I hope you don't think I'm a perv nerd. But I would.
No. And I want to get to know all your curves. The full circumference of your body. You might Make me rise 8 centimeters. What?
Not right now, I'm on my period.
Hey, remember that Greek or Roman god?
Yeah.
Well, I love you.
Really?
Yeah,
I love you more.
and I love you too. Focus.
Yeah! Thank you very much.
Thank you.
Give it up for Joe Vanderhelm, everybody.
Give it up for Kory Mathewson.
Thank you so much.
Keep your hands going for Brad up in the booth.
Woo, Brad! And of course, the incredibly talented Joel Creighton on the keys. Thank you so much.
Lastly, for all of the people who sold you tickets, they sold you beer and Twizzlers, our amazing team of volunteers. Give it up for the volunteers.
Yeah, volunteers.
Everybody.
Yes?
Yes.
Thank you so much for coming out and supporting live theater. We really appreciate it. Without you, it would be so much weirder to do what we do.
Yeah, I mean, we'd still do it and we'd still kiss each other, but no one would see it. And then did it really happen? Yes, because those moments are magic.
Yeah.
But thank you so much for coming. If you enjoyed the show, tell your friends. We got Chimprov every week. If you really like the show, take your garbage with you on the way out so that we don't need to clean up after you. And also, one more time, give it up for Gorgeous and Resonance.
Yeah.
We've been 6 Degrees of Science. Thank you so much for coming out tonight. Have a great night. We'll see you guys next week.
Bye, everybody.
Bye.